Hello all, I'm Naren from the School of Chemical and Biotechnology, SASTRA. This video is part of the Fluid Mechanics for Process Engineers course. We are on Module 3, the first capsule of Module 3, and this module is all about Continuum. Now the suggested reading for this module is the book of Fox, Introduction to Fluid Mechanics. Now let us do this thought experiment, right? We are going to take different volume samples of water. So we are going to measure, let's say, its mass. So that means you are primarily going to weigh it on a balance and then plot the density, right, which is the ratio of mass to the volume of the sample versus the sample volume itself. So this is the thought experiment that I want you to do. What you expect? Can you think for a moment? Right? Do you think that if we plot the density of water versus the volume sample, you will get a constant value? Now you know that the nominal value for density of water is 1000 kg per meter cube. So immaterial of what volume you take, do you expect this? Let me rephrase slightly the thought experiment if you are not able to get it. Let's say the nominal density of water is 1000 kg per meter cube. So that means every meter cube of water will have a mass equivalent to 1000 kg. If I write conveniently in the units of liter, so which is actually 1000 liters will weigh like 1000 kg, which means every liter we know weighs 1 kg. This is what we know. Now suppose if we take, let's say, 1 liter and get the mass, we know that it is 1 kg, right? Or the ratio of m by v in this case, the ratio of m by v in this case will be like 1000 kg per meter cube, or it is like 1:1 in terms of kg versus liter conversion. Now if you do this exercise, let's say instead of 1 liter, if you take 500 ml, do you still get the same value? If you take 100 ml of water, right, do you still get the same? Now maybe then you will take 1 ml of water and then 1 microliter of water and so on and so forth. So if you do this process, do you expect the value to remain same? This is what is the thought experiment I want you to do. Now if you do this experiment in reality and observe, what we see is actually that if as long as the volume of sample is fairly large, this density is going to remain constant. So this will be a density. This roughly let's say 1000 kg per meter cube or 1 kg per liter, or what you say as 1 grams per cc. But if you go to very small values, so very small, so remember now this, if I keep as 0, this is of the order of 10 power minus 6. Suppose if you go to this small values, what you see is a fluctuation, right? You will see a fluctuation because in this case the volume of water has become so small, right, that you really will start seeing molecules. You no longer see water as water, you will eventually see it as molecules. Suppose if I take this as my let's say 1 liter volume representation, and not to scale but a schematic representation of 1 liter. Now I'm saying that in this probably this is much smaller, of probably of around 200 ml or something. So then if I take this is small quantity, and if I take even a very small, and if I zoom this part and then see what is there in this part probably only have a few water molecules. So each of this dot represents one water molecule. So if your sample size becomes so small, then eventually your density fluctuates, right? Now this is one experimental observation. I would like to do another thought experiment as part of this capsule. Now let's say that let's take for example in this case a temperature measurement or a pressure measurement, a probe. So that means let's say this is a system, maybe this is an atmospheric system. So you have, like say this is I'm just sharing it randomly to ensure that this denotes that there is a gas, it could be air, and all you have is you have set a probe, okay, and you are measuring through the probe, let's say pressure, right? Now this could have been even a temperature measurement probe for that matter. So you are measuring here. Now if we ask the question like, what are we really measuring at this point? Is that the pressure or temperature or any such quantity of a molecule at that point? Is this what are we measuring? So when we say the pressure at this point is 1 atmosphere, does that mean there is a molecule at this point and the pressure of that molecule is 1 atmosphere? If we say the temperature at this point is 30 degrees Celsius, does that mean that there is a molecule at this point which I have shown here in this point, and it is that temperature is 30 degree, or do we mean something else? Now if you think of both of these illustrations what I talked about, like in terms of measuring at a given point and also in terms of the ratios, like for example here I have shown with respect to density, you will agree that we don't necessarily mean this quantity of a single variable, but the property we tell, property, this could be any property corresponding to a collection of molecules, rather fairly a large collection of molecules, okay, such that adding or removing some of those molecules are not going to affect any change in the property being measured. So that means we don't necessarily report, we don't necessarily frame in our mind the value of one molecule, the value corresponding to 5 molecules or 10 molecules. We do it a very large number, and it is that number we report. So when we say density fluctuates like this and then fairly remains constant, we do not consider the value that actually comes in this part. Now remember, this is just a fictitious diagram. It could have been like, and somebody could have drawn it in another way also, like this a fluctuation and then it remains constant. So all I want to focus here is not this fluctuation here. The point is, it is not this region that we report. We tend to report the values in this region. This is what we report as value of, like say, density, or when we measure pressure, temperature and everything. So that means our sample volume right? If you say sample volume needs to be in this part, so there is one critical sample volume below which we don't want to go to report any property. So I showed examples of temperature and pressure density. This is in principle applicable to any variable. This is the central crux of continuum. I'll stop here and would request you to reflect on what we have seen. I'll continue in the next learning module. Thanks for watching this video.